Good morning, class, or good day, class. Once again, welcome to our chemistry online class for this week. Today, we'll be talking about salt hydrolysis. We'll be looking at salt hydrolysis. Last week, we dealt with salt, types of salts. We talked about different types of salt, which include the acidic salt, the basic salt, the neutral salt, the double salt, and the complex salt. But today, we'll be dealing or talking about salt hydrolysis. Objective for the class. At the end of this class, I expect you as a student to be able to describe or explain hydrolysis of salt. You should be able to describe the water of crystallization in salt and explain the concept of efflorescent, liquescent, and hygroscopies as related to substances. Salt hydrolysis. What is salt hydrolysis? Salt hydrolysis is the reaction in which a salt reacts with water to form solution which is either acidic or basic in nature. Now, when this happens, the solution of the salt tends to behave like an acid or a base. A good example is your aluminum chloride salt and copper 2 tetrasulfate 6 acid, which when dissolved in water, they form two products, an acid and a base. If you look like the case of the aluminum chloride will react with water to form aluminum hydroxide and hydrochloric acid. The aluminum hydroxide is a weak base, while the hydrochloric acid is a strong acid. Now, you find out that because the hydrochloric acid is stronger than the base, then it makes the solution of the salt in water behave like an acid. Therefore, the solution will turn a blue litmus paper red. The same thing happens for copper 2 tetrasulfate 6 salts when it reacts with water. You find out a base, which is copper hydroxide, is formed, which is a weak base, and also a strong acid of tetrasulfate 6 acid is formed, which makes the solution tends to turn a blue litmus paper red. In the second case, whereby you are having a good example of a salt that behave like a base when dissolved in water, include your triazocarbonate 4 of sodium and potassium. When sodium triazocarbonate 4 dissolved in water, you find out two products is formed. The sodium hydroxide is formed and the triazocarbonate 4 acid is formed. The sodium hydroxide is a strong base that tends to overshadow the triazocarbonate 4 acid and makes that solution behave like a base, in which a red litmus paper is turned to blue. So in such hydrolysis, you are looking at a reaction of salt in water, which makes the salt to either behave like an acid or as a base. Water of crystallization. Water of crystallization is the amount of water found in a salt. The amount of water which is bonded to a salt. The water molecules are loosely bound to these salts and can easily be dissociated from the salt by heating. Thus, note, if a salt is chemically combined with water, if a salt is chemically combined with water, the product formed is called hydrated substance. And that substance is gotten an hydrated substance. And the substance gotten when this hydrated substance is heated to dryness, that is, when the water which are loosely bound to the salt is now heated, the residue or the aftermath substance gotten is called an hydrous or an amorphous, that is a shapeless substance. This implies that water of crystallization found in salt provide two major properties to the salt. One, it gives the salt color, and two, it gives the salt a particular shape. Examples of hydrates include your blue copper 2 tetrasulfate 6 pentahydrate salt. Copper 2 tetrasulfate 6 pentahydrate salt, that is, it is having 5 molecules of water. And you also have iron 2 tetrasulfate 6 hectahydrate salt, that is a salt of iron having 7 molecules of water. Take note, water of crystallization which are found in substance are loosely bound to the substance. They can be removed from that substance by heating to dryness. Calculation on water of crystallization. For example, if you're having 7.47 gram of blue tetraoxosulfate 6 crystal having 5 molecules of water heated in a crucible to a constant mass of about 5.31 gram at the temperature of 110 degrees Celsius, we are asked to calculate the number of molecules of water which is lost. Now, from that information given, we can deduce as the mass of copper 2 tetraoxosulfate 6 heptahydrate is 7.47 gram, while the mass of the dehydrated salt, when the salt is heated to about 210 degrees Celsius, the mass of the dehydrated, that is the residue which is left after heating, is 5.31 gram, while the mass of water which is driven off at the temperature of 110 degrees Celsius is gotten by deducting the mass of the residue from the mass of the hydrate. That gives us 7.47 gram minus 5.31 gram, which is equals to 2.16 gram. Recall, we said numbers of mole is equals to mass all over molar mass. So therefore, we can say the mass of the hydrated salts is equals to the molar mass of the hydrated salt, which is also equals to the mass of the water driven up all over the molar mass of water. Now that gives us 7.74 over molar mass of the hydrated salts, which is equals to the mass of the water lost, which is 2.16 all over the molar mass of water which is present in the hydrate. Now, from the information, we can deduce that 7.47 all over the molar mass of the hydrated salt. The molar mass of the hydrated salt, when calculated, give us 249.5, which is now equals to the mass of the water loss, which is 2.16 all over X molecule of water times the molar mass of water, which is 18. That is how we got our 18S. 18 is the molar mass of water, while S is the number of molecules of water present in the hydrate salt. Now, when this is equated, S can be deduced as 4.008 gram. 4.008 gram. That means that the number of molecules of water lost at a temperature of 110 degrees is 4.08 gram. Efflorescent, deliquescent, and hygroscopic substance. That is, here we are dealing with the nature of crystalline substance. Nature of crystalline substance. Crystalline substance are substance with specific shape. Substance with specific shape. Bear in mind that I said earlier on that water of crystallization present in salt tends to give the salt its color and its shape. So we are looking at nature of crystalline substance, the form in which they exist. One, as an efflorescent substance. Efflorescence is a phenomenon whereby a crystalline substance, when exposed to the atmosphere, lost part or all of its water of crystallization to the atmosphere. Example of such substance is the washing soda. The washing soda is sodium triisocarbonate 4 decanhydrate. Sodium triisocarbonate 4 having 10 molecules of water, and also sodium triisosulfate 6 decanhydrate. Now, when they are exposed to water, they are highly efflorescent. They can lose 9 molecules of water to the atmosphere. Number 2, deliquescent substance. A substance can exhibit a deliquescence nature. What is deliquescency? This is a phenomenon whereby certain substance, when exposed to the atmosphere, absorb a large amount of water and eventually turns into solution. When that crystalline substance are exposed to atmosphere, they tend to take water from the atmosphere, and as a result of that, they dissolve in the water to become a solution. A good example of such substance include your sodium hydroxide. Sodium hydroxide, when it is exposed to water, it takes water from the atmosphere and turns into a solution. Another example is iron 2 chloride, potassium hydroxide, and so on and so forth. So on and so forth. Hygroscopic substance. Hygroscopy is a phenomenon whereby certain substances, when they are exposed to the atmosphere, they absorb moisture, that is water from the atmosphere, but does not form a solution. They don't form solution. If they are solid, they become sticky. They become sticky in nature. Example of such substance include your soda lime, your quick lime. Your quick lime is calcium oxide, copper oxide, also sodium triazonitrate 5. All these are example of hygroscopic substance. Take note, like I said, when they are in the solid form, they don't form solution, they remain sticky. When they are liquid, the liquid is just diluted by the water which it absorbs. With this, we have come to the end of the class for this week. I want to also still appreciate Kayode Precious. He's the only one that is taking the assignments and returning the assignments to me through my WhatsApp number 08034187864. With this helped me to know how many of us are following the classes and how we are taking the classes serious. The assignments for this week goes thus. Number 1, what is a pH scale? Number 2, what is an acid-base indicator? And name 2 any of these indicators which you know. This will help you to prepare for the next class. Thank you. Till we meet again. Stay safe.